welcome to the class. This is CS, what is it?
139.
139, right. If you're at some other class or you're doing quantum mechanics, leave. The rest of you stay. So we're going to spend today talking about the class, and we'll get into the first lecture. But here's the most important slide you are going to have in the entire class, which is the top level node to the syllabus, which contains everything. Everything is linked off of the syllabus. So grab that picture, write down that bit.ly link. And by the way, did you notice that bit.ly has changed? They have an interstitial ad now. I'm deeply sorry about bit.ly's new practice of putting interstitial ad between your click and their getting to the contents. Didn't do it. Okay. So we're going to talk about a bunch of stuff this morning, a lot of process, a lot of mechanics. And for the people who have come in, who have not on the wait list or are on the wait list, we are technically capped. But let me tell you a deep, dark secret. Not everybody who's here will be here in a couple of weeks. They will wander off. They will find a great job in Tanzania, whatever they end up doing. And so we will then fill people in from the wait list. And if you're not on the wait list, just monitor that, and we'll try to get you on the wait list and get as many people in as possible. I think in the past we've had 5 or 6 people enter, so we consumed the entire wait list last time. Okay, so that's the plan, master plan for that.
And also, if you don't get in off the wait list, you're welcome to come on.
Oh, absolutely, absolutely right. And we will go into the details of the syllabus and show you the videos and all that stuff. Okay, so this is the most important slide. So let's do a quick round of introductions. I'm Dan Russell. My PhD is in artificial intelligence in planning, which Peter is going to tell you is sort of the classical era of AI, back when we were youths. I worked for many years at Xerox PARC, just up the hill. Did a bunch of stuff that sort of formed the foundation for a lot of things and tools we use today. I went to Apple, worked there for a while, did a startup, because if you're in the Valley, you have to do a startup. Both Peter and I have done startups. We could tell you those stories offline. I ran a large research group at IBM for a while. Then I joined Google in 2005, and I was there for 17 years. In the search group doing, guess what? HCI, user experience of search. So I did that for a long time. In 2019, I wrote this book called The Joy of Search. And I've taught HCI classes now for around 20 years. And I've taught AI for, I guess it's a new, I need to update that number, like 18 years now, whatever it is. There's my contact information if you need to get a hold of me. There's my personal website, my LinkedIn email. And let me turn it over to Peter. Peter, who are you?
Okay. Hi, I'm Peter Norvig. Like Dan, I'm an AI hipster. I was doing it before it was cool. And we're testimony to the fact that if you work in a field for 40 years, it can become an overnight sensation. So here we are in the real age of AI. I've been collecting all the top level domains. I started out in EDU, worked at USC, Berkeley, and Stanford, moved to .com, even did a little bit of .gov, leading computer science at NASA and .org. I wrote some books. I happened to come along at just the time when, in the 90s, when AI was changing from good old-fashioned AI to modern AI. And with my co-author, we wrote the textbook, and we've been having to revise it ever since, because all the other authors of textbooks says, well, yours is good enough. And so we were stuck with it. And here we are today. And so like Dan, I've done startups and big companies. For me, Google was both of those, because I joined Google when it was 200 people in one building. It's bigger than that now.
Okay. A couple orders of magnitude.
Yeah. Right. So next up, we have our course assistants. So first, Tobias.
Hi, everyone. I'm Tobias. I'm a master's student now, co-chairman at Computer Network Security. I also was actually a human-centered AI track concentration synthesis as an undergrad. I had a lot of fun taking this class last year. I've also worked, I'm not nearly as long as a resume as these two, but Also have some experience in startups working in small language model, post tuning, and orchestration, and then done some security research on campus and some security work for the program.
And next we have,
Hey guys, I'm Adrian. Current coder in CS. Did my undergrad in CS, so taking a lot of AI classes. Took this class. Actually took the first iteration of this class 2 years back. I had a really good time, so let's come back and help out. Currently invested in early capital, so creating $17 billion 11-person fund. I have a lot of experience in industry, so it was a 3 at Meta last summer, it was a 3 at Amazon for 2 summers, done a lot of stuff for startups, and so yeah, if you're ever interested in talking about the space, so you know, government advisors, I'm always happy to speak with that. And yeah, so really excited for this feature, and it's going to be a really fun class. Yeah.
great, thanks Adrian, thanks Tobias. It's really marvelous. We've got 2 course assistants this time, both who have taken the class before, so they know what works and what doesn't work. Having said that, at least half of the class is different than it was when you guys took it. That's just the way that this field works. We are very lucky to be at an era, at a time when AI, as you probably know, is kind of doing its quantum thing. It's growing very rapidly. The human aspects of that are not catching up. And so this course is an attempt to help us, you, the community, be better about understanding how to build human-centered AI systems. So that's really what we're trying to do. So here's our forewarnings, our cautionary notes. This is not a tightly scripted course in the sense of we don't go from chapter 1 to chapter 2 to chapter 3. God only knows if there's a book out there like this, but we don't know of one. So we're not going to follow a single theme. We're going to paint an impressionist portrait of HAI. So it's going to have a lot of different pieces, and we will try to weave this all together at the end. So I know I'm mixing my impressionist painting and my weaving metaphors together, but that's the point. We're going to try to follow the technology as it changes, and trust me, it will change between now and the end of the quarter. Earlier this year, when I taught this course at the University of Zurich, I had an assignment 2, which was basically impossible during week 4 when we handed it out. By week 6, when everybody turned it in, everybody did a great job. In week 7, it became trivial because the AI got good enough to just solve the problem. We're going to try to keep you up on the bleeding edge of all this stuff. So things will change very rapidly, even during the course of this course. So this is really a collection of insights, knowledge, stories, experiences, and a little bit of theory about how all this works and doesn't work. So I think the great advantage of having Peter and I here is we've got lots of war stories to tell you. And that's the real reason to take this course as opposed to just watching it online. Come here, we will tell you what we've actually seen in the trenches. We've been in hand-to-hand combat with AI. We have knowledge under our fingernails. So we know a lot about this topic. So here are what I hope you capture from this course. You can read these slides are all available to you, but I want you to walk out of this class in 10 weeks knowing the basics of how people interact with AI. It's not the same as old-fashioned classic software. Peter's going to point this out in just a couple of minutes. This is not your grandfather's software engineering class. It's not even your dad's, right? So we're going to talk about what the user experiences of AI currently are, where they're going, where they've been, and what we can think about as trying to plan for the future. Along the way, we'll tell you what works and what doesn't work. And we both have a lot of experiences with things that have failed spectacularly. No just ordinary crash and burns, but planet-shaking kinds of errors. We'll also talk about things like the ethical issues involved, because there's always been ethics in engineering, but in AI world, there's all kinds of ethics you might not have thought about. Interesting, deep implications of where your data comes from, who's managing your data, how it affects people in reality and in practice. So we're going to talk about all these aspects, and this is what I want you to walk out. So in week 10, come back look at this slide and say, did Russell deliver? Did Norvig teach me these things? And if the answer is no, come talk to us. We really want to know what failed. Okay. So details of the class. We'll go 10:30 to noon. We have office hours. Interesting. Office hours 10 to 11:30. Well, welcome to my office hour. Reality is we will have office hours back over in the HEI building in Gates Hall right after this class. So you just walk back with us if you don't want to schedule an appointment, or you can email us, email Peter, me, Tobias, Adrian, and set up some time. You can either talk to both of us, or they're more than willing to talk with you on their own. So you can get the people who have actually taken the class experience and their valuable knowledge, or you can get the old hands knowledge. So, or all of us. And so
The office hours will be in room 198 Gates.
right. Oh, that's right. It changed. So we'll update the syllabus. So what we're expecting of you is come to class, because a lot of the class you're going to find out is going to be person-to-person conversation. And as a student, when I was in your chair, I didn't care for that. But we have found that going through the action of talking to your peers and trying to explain something about these concepts is really, really valuable. It's really effective. So that's why we want you to come here. If you can't make it, we put all the material online. So this class will be online. The video recording will be online in about 3 o'clock this afternoon. So come to the class, participate in discussions, and at the end, we have a debrief form. It's just a 1-question survey at the very end of class. It's the last slide of every class. Take your phone, answer the question. It's not a gotcha question. It's basically, were you awake? If you were awake, it's a trivial question. If you were not awake, it's impossible. So it's kind of a sneaky way to take attendance. So we know who's involved and who's engaged. Each session, we will come in, we will go with the AI news of the day. That's our opener. We don't have a monologue, so we just do AI news of the day, which is often just about as funny. We'll then have a lecture, and in the lecture, we'll then alternate with activities. We'll do some labs here, and we'll have lots of conversation, a lot of discussion. And then we have the debrief form at the very end. So it's very simple. So I know you want to know this. We don't fixate on it, but here are the percentages of the assignments. There's a first coming up a little essay. It's 20% of your grade. The second one is a little project. The third one will be a small group project. And the fourth one will be your final group presentation. So the last 2 classes of the course in December, we're going to break up into little groups of 3, 4, 5. You will then do a research project and present it. Come up here and be Peter for 5 minutes, right? We want you to learn this stuff, and we're not interested in busy work, really, really. So if you find you're doing busy work, tell us, we hate this stuff, right? We don't want to do it, whatever. But let us know if you're going to be gone for a while. It was great in Switzerland. When I was teaching in Switzerland, I got messages from people saying, I got to go do my military service. Sorry, I'll be back in 3 weeks. Okay, ready up. So now, one of the things you always have to talk about is what's our policy about using AI in class? You can guess where we're going to land on this, right? We're practitioners, and this is a class about AI, it's a class about humans. So if you're not using AI in this class, you're doing it wrong, right? Pay attention. We want to know what tools you're using, how you're using them. So it says here, tell us how you're using it. Are you using it for brainstorming, spell correction, grammar correction, writing prose, whatever you're doing, let us know. In each assignment, just put a 1-liner, brainstorming, or ChatGPT wrote this essay. You might look not happily about that, but we want to know. We want to understand these things. If you remember one thing from today, here's the one thing I want you to walk out with. If you're not feeling the friction, you're not learning. By friction, I mean the cognitive friction. Learning is not trivial. It's not just like walking down the street. Work at it. And so if you're using the AI tools to write your stuff and you're feeling no friction, trust me, you're not learning anything. And we are not going to use AI tools to grade your assignments. If you're using AI tools to write your assignments, that's one thing, but make sure we're not grading ChatGPT. We want to grade your ideas, your deep understanding, your concepts. We want you to learn this stuff. Okay, so first assignment's handed out today. It's due next week. I hope you'll find it really interesting and relevant. In particular, we're going to front load this class. So you have an assignment this week, you have an assignment in 2 weeks, third, and then we're going to have a little bit of a gap. So you have a month and a little more to do the final project. Because I know how other classes work, so we're doing not what they do. We're doing the opposite of that. Okay, so let's look at this.
And hopefully that could open up the waiting list.
Yes.
Work up front, and if you're not serious about doing work, let somebody else.
Correct. So here's our assignment. Okay, I'm just going to show you what assignments look like. We've got a due date up front, and what we're asking you to do is keep a diary of what AI tools you use this next week for learning, for your personal learning, for your education. This has a couple of goals, one of which is to make you aware of how much AI you're using. For example, you might not have thought about it, but spell correction really is an AI system, right? So when spell correct kicks in, write that down. I used an AI spell corrector, right? So we want you to write that down. There's a spreadsheet here. We want you to keep track of it. You don't have to do it every day, but you can keep track on paper. But at the end of the week, update the spreadsheet so we all can see what everybody's done, okay? And step 2, talk to another student. Interview that student and say, so what'd you use today, Mary? Did you use that? I didn't know we can do that. That's an AI thing. So we want you to be aware and maybe learn about some tools that might be incredibly useful to you. Okay. So interview that person and then write a little essay at the end. Doesn't have to be long, but it should say, hey, I used some AI tools this week and they sucked. And here's why they sucked, or here's why they succeeded, and here's why I'm more brilliant than I was last week. Whatever your experience is. Okay. So what we'll be grading on is basically, did you write something that shows evidence of thought? Okay. That's what we're hoping you do. Then at the very end, just to make sure everybody's on the same page, here's a link. You click here. That's actually the wrong link. I will fix that. Let's try it. See what it does. Yeah, that's not the right link. I will fix that. You will take you to a form where you put in your email address and the link to your Google Doc or whatever. Make that submission editable by us. Okay. So just make it, everybody in the world can read it. And in particular, make sure the 4 of us can edit it because we will leave comments. Okay. Oh, yeah, thank you. There we go. Thank you. That's what the form looks like. Thanks. Okay. So we'll write down your email address. And please use whatever your Stanford email address is, because it kind of Twitter pates my database if you use something at Yahoo, bob@yahoo.com. And that's not bob@stanford.edu, right? So make sure they're aligned. So just put in your email and your name, because inevitably somebody's going to get that wrong. And this is the only way we have to error correct. So we built in redundancy so we can track it down and figure out who you are. Okay. And then just copy paste your link there. Make sense? Okay. So if you have questions, email us, text us, whatever you have to do. Any questions so far? Get everything? Well, if they come up, contact us. So this class has now gone, this is the 5th time Peter and I have taught it. It's the 7th time I've taught it, because I teach it at the University of Zurich as well. But it's had help from all these folks, some of whom you will see probably later in the course. But a lot of folks have helped out here, so it's not just us. This is the master overview of the class, the outline of the class. So we're here at week 1, intro, a little bit of history, a little bit of background. Next week, I'll be talking about mental models and user models and what's the difference between those two and why you need to know. And then you can sort of see the rest of that. fairness, accountability, ethics, self-driving cars, robots, everything. But first things first, since we're going to be doing a lot of discussion in this class, you should say hello to the person to your left, to the person to your right, the person in front, the person in back. You guys in the front row, talk to two different people behind you. You got a couple of minutes. Say hi to everybody. Okay, people. Now you have 4 new friends. So among those friends, you can interview one of them this week when you do your analysis of what AI tools you've used, okay? Okay, so today's class, I'm actually going to turn over to Peter to give our AI news of the day. Peter, it's up to you.
Okay, so we figured out this field is moving so fast. We wanted to keep you up to date, and it's not just what happened this month, but it's what happened this day. This one, we're actually going to go back a couple of days because it's the first day of the class. So this was interesting. Facebook dating adding features to address swipe fatigue. So here the idea is it's too much work for you to decide who would be a good match for you and who wouldn't. So they're just going to tell you. I'm not convinced that'll work, but I can sort of see the point behind it, right? That if you're too picky, then you're never going to match with anybody. And if they just tell you, I set you up with somebody, go on this blind date, maybe that will work.
Or maybe not.
Or maybe not. I'm not convinced that the AI can make a good match, but I am convinced that this idea of just saying you should try this person, that could work. Meta came out with these new take on AI glasses. This is a really interesting thing to me, because to me, it always seemed dumb that I only got 2 hands, and hands are like what makes us human, opposable thumbs and so on. And now I've given up one of my hands to hold my phone. It just seems like a bad form factor. And I always thought there should be something better, and maybe glasses are it. But we've had at least a decade now of people trying to make glasses work, and they're not a thing yet. And Meta's trying once again. And then
with the air gestures.
yeah. So here's another thing, another way to communicate with them, right? If you can't touch the screen, you can make gestures. And this is interesting. So Google and OpenAI were the 2 winners for this programming contest. So these are really tricky programming assignments, and expert coders compete in this. And this year, for the first time, the AI systems did better than the humans. And this is really fascinating to me. So like a year ago, I wrote this essay saying, yes, these AI coding systems are really good at kind of standard problems, but if you take a tricky problem, they all fail on it spectacularly. And I redid it this year, and now they can do them all, and they can do these even harder problems, right? So a lot of progress just in the past couple of days. So I'm going to talk about definitions, history of AI, a little bit of introduction to the theory, and we probably won't get into the final part of the human-computer interaction. Okay, so definitions. So to me, artificial intelligence is building systems that do the right thing, right? It's better to do the right thing than the wrong thing. Compare that to software engineering, but that's also building systems that do the right thing. We'd rather have programs with no bugs rather than programs with bugs. So why is AI not just smart software? And to me, the difference is in AI, the enemy is uncertainty. And in regular software, the enemy is just complexity. So the challenge is navigating this uncertainty, that we want systems that are trustworthy, that they can explain themselves, that they're interpretable, they're robust, and so on. And they're responsible, that they respect these human values and social norms. Regular software, we don't expect it to do all those things. So to get a better comparison, I want to show you 3 types of applications. So in traditional software, think of the software to control a bank. It's really complex, right? There's a million different rules and regulations and fees and taxes and so on. But there is a correct answer down to the penny. Now, compare that to old school AI, like the chess playing program, which even a decade ago, these programs far surpassed any humans. And then modern AI, self-driving car. And here's all the difficulties. So for the banking problem, there's really two problems. One is the complexity. To build a system for the bank, you got to deal with that complexity. To build a system to play chess, there's a problem that your opponent's going to be doing something you can't predict, that you have to think ahead multiple steps, not just one step.
I have to interrupt one more time. Sorry. Go back to meeting. I have to admit, Adrian. Okay, there you go. Can't type while standing in here.
Okay. And then the other problem in writing a chess program is the computational complexity, that there's lots of moves, and when you multiply that out, there's too large a number to explore them all. Now, compare that to self-driving cars, where you have all those issues, but on top of that, there's all these new issues. So one is we call partial observability, meaning you can't see everything in the world. You can't see that there are cars around the corner or there's a pedestrian about to step out. That's not a problem in these other applications. In chess, you can see everything on the board. In banking, you can see every transaction. It's a dynamic world. If you just wait, bad things can happen. That's not true playing chess. All right? You can wait and the pieces aren't going to move while you're doing nothing. There's multiple things you're trying to achieve. In banking, you're just trying to add up the numbers correctly. In chess, you're just trying to win. But in self-driving cars, you're trying to get to the destination. You're trying to make the ride comfortable. You're trying to not get into an accident, and so on and so on. So there's a lot of new problems to deal with, and that's why we think of AI as being separate, and not just, let's just do more software. And here's an example I used to illustrate that, right? So I got this pop-up on my phone a couple of years ago. This was before generative AI, and I said, oh, isn't this great? So Google parsed my email from Hertz. They put it into my calendar. They popped up an alert on my phone. They drew a very helpful map. Everything about that was awesome. And then they said, time of travel, 23 minutes by bicycle. So on the one hand, this was kind of smart because I'd been commuting to work and it was about that same distance. So it learned that I like to travel by bicycle. On the other hand, it did not know what it meant to return a rental car, right? And I thought, okay, I'm a Google employee. I should file a bug report. And there's a pull down list that says which team is responsible. And I said, wait a minute, kind of everybody did their job. And I could suggest that if it's an email from Hertz, don't say travel by bicycle. But if you fix that one, you can, yeah, sure, you can fix that with a couple lines of code. But then there's like thousands and thousands of other similar things that would also require code. So basically I'm saying, should this program, which is just putting up alerts from your calendar onto your phone, should it know everything there is to know about everything in the world? And the answer was no. You can't expect software to do that. Regular software, that's out of bounds. I can't really, in good conscience, say you should fix that. But with AI, maybe you can fix that, right? And so sort of in the last year is the first time you could write a program that could solve problems like this. And so I tried, and when ChatGPT 5 came out, it did pretty good. It says, riding your bike to return a rental car sounds like an amusing plot twist, but logistically it's tricky. Well, it's actually kind of a little bit more than tricky, but it got the idea here that that was not a good idea. However, it's non-deterministic, right? And so I just changed the words of the query just a little bit and asked again. And this time it says, that depends on a few practical factors. And so it completely missed the point. And I think what's going on here is these systems have been overtrained for safety, right? They said safety is job one. And so what ChatGPT is doing here is saying, oh, this is a question about bicycles. I know whenever you ask about bicycles, I have to worry about the distance and the time and the weather and so on. And I have to tell people to be safe with a bicycle. And it answers that part, and it forgot about the rental car part, right? So what can we do with these systems that have this amazing capability, but they also screw up half the time? And that's the challenge of building with AI in the current era. Okay, so talk to your neighbors who you've already met for a couple minutes, and how do you think about what's this difference between what makes AI special compared to regular software? Okay. Stop. Stop. Good. Great conversation. Does anybody have something they want to share about their discussion? What did you guys talk about? What's an interesting piece of software, or what did you? Yeah.
There isn't always a very strong distinction between the two. But something that did come up as a pattern is that AI needs to have data to be trained on.
Mhm.
So even though you could have software as a model, it still needs to have like knowledge that you're feeding into it. Oftentimes it's kind of circled that like AI is only as good as its data. So we were kind of just talking about that difference where like AI is still software, but like the biggest difference is that you're feeding it certain information. And that makes it like a good model or like maybe a less good model.
Yeah, so that's a great point. We're going to talk more about how data fits into the AI. Anything else? Yeah.
We talked about how with software you usually have specific inputs in mind. Whereas with AI, we would want it to have like a human intelligence so that it can like reason about inputs that it doesn't recognize and then produce an output.
Yeah, I think that's right. Right. So regular software, you kind of have particular journey that the users can take, and for AI software, it's much more open-ended.
And the other side of that is we talked about software has relatively deterministic outputs versus AI and not deterministic. So you have more control in software, but also it's more rigid, whereas you have more flexibility in AI, but it also means you don't have as much control.
Right. Okay, great. All right, let's move on. Good discussion. So I want to talk about what makes things different this time. Right. So here's a brief history of AI, and Dan and I have been around long enough to see a bunch of the ups and downs. And there've been times in the past when, all the newspapers and TV was saying AI is really here, and it never quite happened. So how is this time different? And I think one of it is we have the data, as we heard, that's important to AI, and that's really available now. It wasn't in the past. We have the computational power, and we'll see more about why that's important. And we've got some algorithms that are more general. I think that's probably not as important as the data and the computing power. And then there's all this interest and excitement and investment and so on that helps push us along this time, right? So here's these charts, always going up and to the right. And so and these are log charts, so it's exponential. The amount of data we had is going way up every year, amount of computation. And so for most of that chart, this is Moore's law, doubling every 18 months or so. But for the last couple of years, it's accelerated beyond that. And that's because of these parallel processing GPUs and other types of specific hardware that we found the right application for how they match up with AI. And so now we're moving even faster than Moore's law was in the past. And then the algorithms contribute to that. So we get smarter and smarter about how to write algorithms to use all this data and computation. Okay, so types of AI. In the old days, we had these things called expert systems, where you would go out and interview an expert, say a doctor, and say, how would you solve this case? And then by hand, try to write down code that would duplicate the way that the doctor thinks. Then we moved more to machine learning, saying, instead of asking you what we do, we're going to show examples. Here's an example. Here's all the records on the patient. Here's the diagnosis. Try to make a system that will learn how to do that. Deep learning is a phrase we have now, and it just means that we're going to do machine learning, and it's going to take multiple steps rather than trying to go direct from the input to the output. And then artificial general intelligence, a vague term, and everyone has different meanings for that, but it kind of means it can do everything and do it as good as a person or maybe better than a person. You ask 10 different people and they'll give you 10 different definitions of what it is, but it's something out there beyond. And here's another way of just looking at those possibilities. Okay. Then the final definition I think I want to do is for human-centered AI. And there we want the benefits to be fair and the harms to be mitigated for humans. And we want to focus on multiple levels. So for regular software, we have this idea of user-centered design. You say, who's the user of my software? Let's build something that's good for them. But I think with human-centered, we definitely want that. But then we also want to say, who are the other stakeholders? And what's the effect on society as a whole? So you can't stop and just say, the user's in a vacuum, we're going to build something for them. You have to say, who else is going to be affected by this? And we want it to be compatible with the way humans work, their brains and their behavior. And we want to augment what they can do rather than replace them. And at some point, there will be some cases where a human is no longer needed to do this job. But mostly what we want to say is, how can we help people be better at what they do rather than saying, push people out of the way? Okay, and in order to do that, it must be understandable and usable. So one of the big questions is, who are the stakeholders? Who matters? And what stakes do they hold? So let's look at some examples. So there've been software to help judges make bail decisions. Here's a defendant. Should we let them out on bail or should we keep them in? One of the factors is, are they likely to recommit a crime? And if they are, probably we don't want to let them out. And there've been AI systems that try to make that prediction to help the judge make the decision. So the user is the judge. And yeah, we should make a great system for them with lots of charts and figures and data so that the judge can see what's going on in this case. But there are also other stakeholders, right? So what are the defendants' rights? We don't want to be biased against them. What about the victims of past crimes or possible future crimes and their families? What about the effects on society as a whole of mass incarceration or perpetuation of bias, right? So if you just build a great system for the judge, you haven't completed the job. You got to think about where this all fits in. So similarly, for a self-driving car, the user is what we used to call the driver, which is now the person that's sitting there and going for a ride. And the stakeholders are, what about the people in other cars? We don't want to crash into them. We don't want to cause traffic problems with them. What about pedestrians? We want to make sure we can spot them, and the effects on society. How does our society change? How do cities change, right? So some people saying self-driving cars could make things much better. Others are saying, well, now what will happen is people will just live 2 hours away from work and they'll sleep in their car on the way home, and then there'll be even more cars on the road. What's the quality of life for these people? And kind of for all these applications, there's these issues of wealth redistribution, right? So if the benefits of AI are a few companies get super wealthy and people don't, that could have a negative effect on our society. Okay, now, separate topic. I want to talk about this, because we're talking about self-driving cars, I want to talk about this one-dimensional automation model of AI, right? So this is saying what AI does is automate something, and we had low automation, right? In the old days, you had to turn the crank on the car yourself, and we have high automation where you can just sit back and relax. And often AI is thought of as being somewhere along this one-dimensional line, and the more automation you get, the less control you have. And sometimes that's okay. And here's this diagram from the Society of Automotive Engineers. They have these 5 levels of self-driving cars, and that's great, right? So you can say, Tesla's at a 2 and Waymo's at a 4 or whatever. I have no problem with these levels. I think they're helpful. What I think is interesting here is look at the diagrams at the top, right? So here I am at level 0 and level 1, and I'm behind the wheel. And at level 5, I disappeared. And maybe I want to disappear sometimes. Maybe I just want to say, get me to my destination. I don't care how. But sometimes I don't want to disappear, right? I want to be in the loop. And I want to be telling the car, no, don't go that way, go faster, go slower. I want to be in control at some point. And so some people, particularly Ben Schneiderman's associated with this, is saying, maybe we want a 2-dimensional matrix rather than one, saying, I want trade-off of how much automation I want to help me, but I also want trade-off of how much control I want to maintain. And I could be in any of those quadrants, right? So I could say to my self-driving car, yeah, I want you to take complete control, or I want you to give more control back to me. And here's an example I like, right? So in this left panel saying AI turns this single bullet point into a long email, and I can pretend I wrote it, and then the boss gets it, and I said, I got this boring long email, and I can turn it into a bullet point, right? And so if you didn't think about the use cases, both sides might be saying AI is doing something good for me, but in the end, AI is doing nothing, and it all cancels out. Okay, so discuss with your neighbor for a couple minutes. What's the difference between human-centered AI and regular AI? Describe an application of your choice and say, where does it fit in terms of this user, stakeholder, society framework, and where does it fit on the low-high automation and low-high human control? Okay. Up. Up. All right. What'd you guys talk about? Who has something they want to share with what they talked about? Which applications did you choose to discuss?
So we talked about how like AI, they can fit all the basic frameworks trying to use chat. So human-centered AI is making sure that it's augmenting whoever's using it and not replacing them or creating crimes, because there's been a huge issue with AI, like creating like deep fakes or videos or photos of people with like suspicion and stuff like that. So human-centered AI is making sure that it does not do anything bad.
Great. Yeah. Good comments. Thanks. Anybody else?
Talk about a few applications. One of them we spoke about was AI in medicine, and involves a lot of stakeholders, obviously, and how if you have AI tools for say physician workflows, the user is a physician, but the stakeholders are the patient, their family, maybe the rest of the care team, broader society, community, and the healthcare system, and so that involves a lot of other people where AI should be.
Yeah. Excellent. Thanks. Yeah.
One of the things that we discussed was trying to figure out what the boundaries between like augmented reality would be, because it's hard to imagine a system that's like good enough to never make mistakes to help you with the decision and not be the best to make that decision. So just trying to figure out what that would be.
Right. Yeah. And we've always had that, right? So using a shovel is easier than digging with your hands, and using a bulldozer, you can do a lot more. But in the past, it was clear that those were augmenting, because the shovel or the bulldozer wasn't going to do the work by itself. So it may replace some workers, but there's always a worker in the loop. And now, sort of for the first time, say it's possible to do it without anybody. There's something in back.
You talked about like AI for aircrafts.
Uh-huh. Yeah. Yeah, so aircraft's an interesting application, and in some ways we've had that for many years, right? So there's been these autopilots, and we don't, for some reason, we don't really call the autopilots AI. maybe because a decade ago that was too scary a term, but they are a form of AI. And Professor Michael Cochrander in this department here at Stanford helped build the system that keeps our aircraft safe by communicating with each other. And that's another important part of it. Okay, so talk about augmentation, not replacement. This is an example. It comes from our colleague Eric Brink-Jolson, and he talks about, the ancient Greeks, they had these myths of robots. And Talos was supposed to be this giant bronze robot. And so we've been thinking about this idea of having AI or having robots for thousands of years. But if it was just augmentation, right? So say you were an ancient Greek and you said, okay, here's a robot and it's real and it can do some of your tasks for you. And then what can you say? It's like, oh, awesome. Now I can produce more Greek urns faster than before. But, I still won't have medicine. I won't have airplanes. I won't have all these modern conveniences. I'll just be doing the same things I always did a little bit faster, right? And, maybe I'll have this robotic chariot. And so if I wanted to send a message to my friend in Marathon 26 miles away, it would only take 1 day instead of 2 because this robotic chariot could go there and bring a message back. But I wouldn't have a telephone or internet or any of those things. So if you just talk about how can I do an existing task a little bit better with the robots, you don't get that far, right? Really what changes society is saying, we want to invent new technologies. We don't want to just do the old stuff better. We want to invent new things. And I think that's the place that AI can really fit in. So here's a brief history of AI. I talked about in the 80s, we were talking about expert systems. And the emphasis was really on the algorithms, right? And so I was there, and I'm trying to get my papers published. And if you want to get your paper in a journal or a conference, what you had to do was say, I invented this algorithm and it's better than anybody else's algorithm. Therefore, you should publish my paper. Then around in the late 90s to early 2000s, things started to change. We had machine learning and then we had big data. And we started to realize, yeah, it's great to have a better algorithm, but if you want to make your system a lot better, it's easier to do that by adding in more data rather than by trying to come up with a better algorithm, right? And the bigger advances were by getting better data, and the algorithms made less of a difference. And then more recently, we said, okay, now we've got the algorithms, we've got the data, we've got the computing power, and the hardest part is now become saying, what is it that I'm trying to optimize? What is my objective? So we have this amazing mechanism that says you can optimize whatever you want. But we keep on making mistakes of saying, well, I tried to optimize this objective function, and then I found out that it was biased or it wasn't really what the customers wanted. And we have these decades of experience of saying, how do I build better algorithms? How do I deal with data better, right? So the industry has built that up, but we don't have that kind of experience for saying, how do I really say what it is that I want and what's the right thing to want? We haven't figured that out yet. So that's the hard part. The methods we have went from handwriting knowledge down, right? So it was the blood, sweat, and tears of graduate students like me in the 80s who had to write things down by hand, to saying now we just learn from data. And then more recently, it's all prompt engineering. And then we moved from pure logic to probability and statistics, and now optimization. And then here's some heroes of each of those different eras. Okay, so what were AI systems in the past? So one of the first was kind of the first chatbot from 1964 from Weizenbaum at MIT, and he built this system, and you could have a conversation with it. And people were convinced. So this was a terrible system, right? It didn't know much of anything about the world, but it just went by keywords. right? And so it had something that said, if the word alike is in the sentence, then respond with in what way. And it was just built like this. It ignored 90% of the input and just spit out some canned response. But people were hooked on it. Just as people now are hooked in talking to their chat GPT as if it was a friend, at that time they believed in it. It just goes to show how gullible people are and how much we sort of want to believe. Then in the 1980s, there's this famous program developed here at Stanford that understood molecular structure and made predictions and sort of understood how chemistry worked. Famous case in 1997 when IBM's Deep Blue beat the world chess champ, and then in 2011 beat the Jeopardy champ. So these were systems that could solve specific problems, but weren't general in the way AI is today. So today, we have some systems that are kind of using the old technology but still exist, like the Roomba robot. We have advances like AlphaGo, which beat the human Go champion. That may not sound too much different than beating the chess champion, but Go is a lot more complicated, right? Just orders and orders of magnitude more complicated. And you can't use the same techniques that you use in chess. In chess, you can kind of think through all the possibilities. In Go, you have to kind of perceive the board as a gestalt figure and figure out from there. And so we needed these kind of neural net approaches on top of the old-fashioned search through all the possibilities in order to get there. We've got drones doing imagery, we've got AI art, we've got chatbots, and we've got self-driving cars, and so on and so on. Okay, so as a precursor to your assignment, talk to your neighbor about an AI system you've used recently. What did it solve for you, and how could you improve it?
So,
Okay. Stop. Okay. End the discussion. Let's bring it in. All right. All right. You're all excited to be AI engineers and improve your products. What products did you talk about? How would you make it better?
He used ChatGPT to the system to create practice tests. We better one
Yeah.
practice test for class and then generated 10 more.
Yeah, that's a great usage. Okay, anybody else? Yeah.
It's not quite LLM, but I use Maps, which I think uses AI to develop their routes.
Oh, yeah.
Apple Maps.
Yeah.
This would solve the navigation route, except the thing that I kept running into when I was driving home from work is that it always added traffic time, and it seemed, I don't know, predictable how that it was always going to add traffic time. So I would put it in, but the navigator didn't as well as I'd hoped. So that would be where I wanted to improve.
Yeah.
That was Apple Maps.
Yeah.
Yeah.
Explains it all.
Yeah, so Maps is a good application, right? And it's kind of crosses this threshold, right? So some of it is good old fashioned AI and algorithms. We have these algorithms say, here's a graph. How do you traverse it? And what's the optimal place to get from one place to another? That's a classic problem in computer science. But then there's kind of this AI layer on top of that of saying, well, it's not just a static map and it's 1.5 miles from here to here. It's what are the traffic patterns right now and what are the traffic patterns likely to be during your route so that I can predict that you should go here or there. And that's part of it. And then it's become even more complicated lately, and it's become sort of this game theoretic aspect of saying, well, if I tell everyone to go down this route, then that road is going to get more crowded. And then there are people fighting back, right? So there are people saying, oh, it used to be all the cars went on the main street. Now they go off into the neighborhoods and they're driving by my house and I don't like it. And people are trying to combat that in various ways. So it gets complicated. Yeah. Anybody else? Yeah.
So I use Gamma to generate a PowerPoint presentation. And it was very fast, and it's also very presentable. But one thing I want to improve on is the style of the presentation, because it is like kind of cartoon style, but I want to use it for a business presentation. So I hope that I have worked more on the style.
Yeah.
And also some inputs that I think. So in the like text, it is not so observable, but it's moved to the presentation. Like some numbers or some figures to be like very high.
Yeah. Yeah, so that's an interesting one, right? Because it does feel like one that's moving very fast, and there's things that work well now and things that don't work, and in a couple months it will definitely be better. And secondly, we can see this change in what can be done by you individually versus what used to be done by a professional, right? And we've had that before, right? So it used to be, if you wrote something, you wrote it out by hand with a pen, or maybe you used a typewriter. And then if you wanted it to look good, you had to bring it to a professional printer, and they were the only ones that could do that, right? And then we got desktop publishing, and all of a sudden you could do it. In some sense, they said, oh, is that putting printers out of business? Turned out not really, because there was just more and more demand for that. And we'll have to see how that plays out with art, right? So in some sense, there are places where you would have gone to professional artists and say, make this presentation for me. Now, some of those are going to be out of work, but there's also this opportunity to say, I want this presentation to be really excellent. And for that, I'm willing to pay a person to do a better job, and they can use the tools and they can do a better job. So I think there'll be a mix of the high end versus the low end, right? I mean, you and I, we were never in the market of paying a professional to make our slides for us. So they haven't lost any money for us. But in the higher end of the market, there is a change in who does what, how much is done by an individual, how much is done by a professional, and is the value of a professional worth more or less? And it seems like there'll be fewer professionals, but they will be even more valued because they're a differentiator. Okay, let's move on. So the other thing about AI is that there are many closely related fields. So that means we're going to have many Venn diagrams. Norbert Wiener in the 1950s, I guess we have here, started in 1948, invented this field called cybernetics, which meant the automated control of processes. And it combined all these different things, and they're all related to each other, right? So we had cybernetics in the middle in 1948. During World War II, this idea of operations research, of how do we get all these troops into the right place at the right time, became a mathematical science. After the war was applied to business, had this idea of control theory, of how do we make something go to the right place at the right time. Information theory came in around that time due to Shannon and others. Artificial intelligence was a few years later. So all these fields developed. There's a lot of overlap, but they were all solving slightly different problems and with different communities. And so they could have got together and said, you know what, we're all doing the same thing. But they didn't, because one field said, I'm trying to solve this problem. Another one said, I'm trying to solve this problem. And they didn't really see the commonalities between them. Here's a famous diagram of what is data science by Drew Conway. And he says, well, data science is a combination of, you got to have a little hacking skills. You got to know some programming. You got to know a bunch of math and statistics. And then you have to be an expert in your subject area, whether that's medical or chemistry or whatever the subject area is that you have the data from. And data science is there in the middle. Notice he has this danger zone here that says, if you know something about your field and you just go ahead and start programming without knowing any statistics, you're liable to make a mistake. Then Joel Gruss did an update on this. So he introduced the evil side, saying, here's another thing that can go wrong. What if bad guys get control of these technologies, and what can they do? And so that was kind of interesting and fun. And then notice he also says he thinks that not knowing your stats maybe isn't all that dangerous in retrospect. So yes, you can make mistakes, but most of the time, if you have a lot of data, it's going to tell you the right thing. And the statistical knowledge is really important when you have a small amount of data to not make mistakes. But if you gather enough, usually the data is overwhelming. It's less likely to make mistakes. And notice that your thesis advisor is the one that's evil and doesn't know how to program her, and your grad school office mate is the one who does know how to program. Okay, and then we've got user experience design and user interface design, right? So the user interface design is what's on the screen, can we make that pretty and easy to use? And the user experience is, how does that fit into your life? Okay, and then another take on it is human-centered design, saying, look at the technology, yes, but also look at what the people are that are using it and how the business case for that fits in. And human-computer interaction. So everybody's got this take on how these fields interact. The details of them aren't important, but what is important is that it is sort of going across boundaries, and making sense of this means you have to look at it from multiple different points of view. Okay, we got 10 or 15 minutes left. So I want to talk a little bit about the theory of artificial intelligence and machine learning. And so I think of artificial intelligence as agents acting in an uncertain world, right? So you've got this agent here, and they've got some percepts, they've got eyes, or some way of observing the world, and they've got actuators or effectors that can interface with the world in some ways. If it's a robot, they've got legs and arms. if it's just a piece of software, they've got input and output, and they're interacting with the environment. So the environment is telling them something, and they're making some actions back. And so the real question is, what is it that goes inside the head, so to speak, of that agent? How do we fit what's in there? And the way we think about it is the agent has this model, and into that model, you pour in some prior knowledge, some data and some instructions. And we call that the training phase of we take this previously empty model and we fill it up with that knowledge and data and train it so that it can do this task. And then we give it an input, ask it to use your previous knowledge and data and come up with an output, and that's the inference phase. So that's how we build these systems. And so I think the important thing to me is AI is a process of showing, not telling, right? So previously in software, it was, I'm going to tell the computer exactly what to do by typing out code in Python or Java or whatever. And in AI, we're showing it. Here's a picture of me with my mom, and she's showing me something. I don't remember exactly what it was. And then here's a picture of a traditional software engineer. And this is Margaret Hamilton. You might have seen this picture. So she's credited with coining the term software engineering. And this is the assembly language code for the Apollo mission that she was in charge of software for. And true fact, she was my boss in my first job out of college. How awesome. Right. So that was amazing. But I got to say, this picture keeps on popping up, and I always think back to those days and that job. But also, whenever I see this picture, it kind of reminds me of this picture. Right? And I think there's an analogy there. So, Darth is kind of strangling this guy, trying to get him to do what he wants to do. And that's often what it feels like when we're debugging software, right? It's like, you're doing the wrong thing. I got to fix it. How can I do that? And AI is different, right? So we don't debug AI the same way we debug software. We show it what to do rather than tell it step by step. And, nobody likes to micromanager. Darth never won Boss of the Week awards. But showing rather than telling is sort of a nicer way to do it. So how do we do that? A lot of what we do is by supervised learning, right? So I want to build a system to separate cats and dogs. I go out and get a bunch of pictures and I say, these are the cats and these are the dogs, and that's my training data. And sometimes they're going to make a mistake. Right? So this one looks like a cat, it's actually a dog, and vice versa. As long as there's a small number of mistakes, it's probably okay. And one of the interesting aspects is, where does this data come from? So where do we get the pictures? And who labeled the data? And what are the conditions like for these people that are creating the data for you? And are we treating them fairly, right? So we think of all the stakeholders, the people doing this labor to create the data, they're part of the stakeholders too. Okay, so let's make this, take a step back and say it in a very abstract way. I got some data. There's some input variable X and some output variable Y, and I want to understand that data. So one of the things I can do is I can build a model, and I can say, well, here's a linear model, right? So if I had to draw a straight line, I can do that. It fits my data. And now if I want to predict what would be the value, if I gave it this input X, what would the output Y be? And I can say it's the number that's on the line there. Right? So essentially, that's all that AI is doing, except here it's a two-dimensional model, and for AI, it's a 2 billion dimensional model. And there's more data, right? So that's one answer, but this linear model, that's just one possible model, right? So there's other things we could do. It's called the nearest neighbor model. Here's this interpolating model. Here's a cyclic model. It has a sine wave in it. Here's a polynomial model. Right? And so these are all possibilities. And the data doesn't tell you which one of those is right. Right? So that's up to the analyst to say, do some of these make more sense than another? How am I going to figure that out? So how do we do this training or learning phase? So one way to do it is say, I got the data, let's make a guess. Let's say we're going to use a linear model and I just make a guess. This looks like a good guess. Then I add up all the errors for how far off I am. And then I make an improved guess that tries to shrink those errors. And that's basically what we're doing. And we can draw it like this. So this is a different two-dimensional plot, right? So here we have the X and the Y. Over here, we've got the values of the parameters. And then in the third dimension, there's this loss here, saying how much bad off were we? And we start off at a point where we have lots of loss, make lots of mistakes, and then we slowly move down, trying to find the bottom of this hill where there's a minimum amount of mistakes. And one of the amazing things is that these modern AI systems usually work. We start going downhill, and we hit a point where there's very little error. And it could be that we kind of got stuck somewhere and we didn't find the right place. But because of the way we build our systems, they are able to do that. And that's the amazing thing about the way modern AI works. So we call that gradient descent. We're going down the gradient. There's calculus for that. But basically all we're saying is, you know, take a marble and put it on that surface and let it roll downhill. And then it will find a place where there are good parameters. You can also call that the Kaizen method. So this is a method of continual improvement that's done in manufacturing. There's a great video by John Cleese about Gordon the guided missile. So he imagines a children's story about a guided missile who is continually making mistakes and going in the wrong direction, but then slightly decreasing the mistake to hit the target at the end. So why don't we stop there, and we'll pick it up next week.
Before you walk away,
But we got to do.
We're going to jump to the, there you go.
This one, or
Yeah. There you go. So
Yeah.
go ahead and fill out the form. This is our debrief at the end of class. I will be putting out the video of this and the slides onto the syllabus, so you can check all this stuff later, okay? And we will pick up Peter's lecture on Thursday from slide 68.
Okay.
All right. See you on Thursday.
So, and it's Peter, I'm a DC, I'm not on the wait list or anything. He said persevere.
yeah.
Persevere.
Persevere.